Hey, welcome back. So today we're going to crack the code on one of the most powerful tools in all of math, matrices. We're going to break down the basic operations that literally power everything from your favorite video games and photo editing apps to huge, complex data analysis. All right, let's just jump right in. So let's start with something you've probably done 1,000 times. You take a photo, it's a little dark, you slide that brightness toggle, and poof, it's perfect. How on earth does that happen? I mean, it feels like magic, right? But behind the scenes, your phone is actually cranking through millions of calculations. And the answer, believe it or not, is actually super simple. It's exactly what we're talking about today. You see, that photo is really just a giant grid of numbers. And that grid, well, that's a matrix. And that little brightness slider is just triggering one of the most basic matrix operations there is. Okay, so first things first, let's start with the most intuitive operation, adding and subtracting. This is the bedrock, the foundation that pretty much everything else is built on. Adding two matrices is incredibly straightforward. All you have to do is add the numbers that are in the exact same spot. The number in the top left corner gets added to the other top left corner, bottom right gets added to bottom right. You get the idea. It's a perfect one-to-one matchup, element for element. Okay, but here's the absolute biggest, most important thing you need to remember. I call it the golden rule. For any of this to work, the matrices have to be the exact same size. Their dimensions have to match perfectly. You can't add a 2x2 matrix to a 2x3. It doesn't work. Seriously, no exceptions. Okay, let's actually try one. We've got matrix A and matrix B. They're both 2x2, so check, we're good to go. We take the 1 from A and the 5 from B, add them up, and we get 6. Then we do the 2 and the 6 and get 8. You just keep doing that for every single spot and boom, there's your final matrix. See? Simple as that. All right, on to our next core idea, scalar multiplication. If adding matrices is like combining two grids of numbers, you can think of this as kind of like putting a magnifying glass over one single grid, or maybe turning up the volume on the whole thing at once. So the big idea here is that you've got this one number on the outside, we call it a scalar, and it gets multiplied by every single number inside the matrix. I mean it, every single one. Not just the first entry, not just the corners, all of them. That one number on the outside affects the entire matrix. And that's why that whole stretching or shrinking analogy is so perfect. When you multiply a matrix by, say, a scalar of 2, every single value inside it just doubles. It's like you're making the whole thing twice as intense, all at once, without changing its fundamental shape. Okay, so we've got our two main tools in our toolbox, addition and scalar multiplication. So now let's put them together and tackle something that looks a little more intimidating on the surface, but you'll see it's actually totally manageable.
So here's the problem. What's 3a minus 2b? We just follow our good old order of operations. First, we'll handle the scalar multiplication. We take matrix A, multiply everything inside by 3. Then we do the exact same thing for B, but multiplied by 2. Now we have two brand new matrices, and we just subtract them element by element. And pay close attention to this one right here. 0 minus a negative 4, that becomes 0 plus 4. That's a classic spot to make a mistake. And just like that, you see how all the rules just stack together perfectly?
Okay, so all this seems pretty straightforward, right? But there are a few common traps that are super easy to fall into. So let's just walk through them real quick so you can steer clear. Just take a second and think about it. For addition and subtraction, what was that one golden rule we talked about? The one with no exceptions? Because that right there is the source of the #1 most common mistake.
Yep, you guessed it. It's that dimension mismatch. A 2x3 matrix and a 3x2 matrix. Yeah, they both have 6 numbers inside, but their shapes are totally different. There's just no way to add them. The little numbers inside just don't line up. You'd have some left over with no partner to add to. So for that reason, we just say the operation is undefined.
So let's wrap up this danger zone section. Your top 3 things to watch out for are: number 1, always check your dimensions before you add or subtract. Number 2, when you're doing scalar multiplication, make sure that number hits every single entry inside. And number 3, be so careful with your signs, especially when you're subtracting a negative. That's a classic trip up. All right, we've gone through the rules, we've looked at the traps. Now for the really cool part. Let's circle all the way back to our photo editing example and see exactly how this stuff works in the real world. This is where it all comes together. So get this. At its most basic level, a digital image is just a matrix. That's all it is. This is a tiny 3x3 grid of pixels. Each number just represents how bright that one little spot is, maybe on a scale from 0 for pure black up to 255 for pure white. I mean, the screen you're watching this on right now, it's just a giant, massive matrix of pixels.
So how do we make that image brighter? It is literally just matrix addition. You take your original image matrix and you add another matrix to it where every single number inside is 50. What's the result? Every single pixel just got 50 points brighter. That's the brightness slider. It's not some crazy complex magic trick. It's just math.
And here's what's really mind-blowing: the scale of it all. A single photo on your phone has millions of pixels. So when you move that little brightness slider, your phone is doing this super simple addition millions of times in less than a second. It is absolutely fundamental to how our technology works.
So I'm going to leave you with this final thought. Now that you've peeked behind the curtain and seen how something like image editing is built on these really simple rules, where else is this happening? Where else in your daily life is this kind of math hiding in plain sight? Think about 3D graphics in video games, audio equalizers, or even the recommendation engine that might have pointed you to this video. Matrix math is, quite literally, everywhere.